All right, guys and gals, let's go ahead and get started. We've continuing our lessons that we've been talking about the past couple of days. We've been in this probability chapter for a couple of weeks now. We're starting to head towards the end of the chapter. And one of the last things we're going to talk about in this chapter, which we talked briefly yesterday before class was over, but we talked about the differences between permutations and combinations. All right. So if you look at the example problems down at the bottom, we're going to have an event that occurs, and it's going to be our job to determine whether it's a permutation or a combination. So this is going to require you to dig back and remember some information from the past couple of days. Permutation, combination, when does order matter, when does order not? Okay. Before we dive into the problems, let's go ahead and practice some of this calculator stuff because that's what we're going to be typing in. All right. So before we actually look at the computation problems, let's go ahead and make sure that we review where these buttons are in the calculator. All right, because we're going to let the calculator do our work for us today, just for this content. All right. So look at example 2. 6 permutation 3. So we have 6 things that we're choosing from, and we care about 3 of them. We're trying to put 3 of them in order. All right. So just like yesterday, we're going to dive in and we're going to do 6. Anybody know where the calculator buttons are from yesterday? Good. You're going to hit math, and then you're going to go over to probability, PRB. Now be careful, you have to choose between NPR and NCR. And for this exact problem, we're going to choose NPR. We're going to type in the number 3, and we're going to hit enter. Okay. And the calculator tells us that if we have 6 things to choose from, and we want to put 3 of them in order, that we have 120 possible outcomes that this could happen. All right. Let's look at example 3 before we move on to any words. All right. Now for example 3, we've got a couple of larger numbers. Doesn't make it any more complicated. 13. We're still going to go to math, PRB. But instead of choosing NPR this time, we're going to choose NCR. Okay. So we've got 13, NCR. Then we're going to type in the number 7, and we're going to see what our calculator tells us. So the calculator is saying that if there are 13 things to choose from, and we're going to choose 7 of them, but we don't care what order they're in, that means there's 1,716 possible ways this could occur. All right. So now that we know where those are, we need to start making some decisions once we see these word problems. Try to decide whether it's a permutation or a combination. Right? Now, before we dive into the problems, let's review what those 2 words mean real quick. Okay? Does anybody remember what permutation, what the definition of that is? Okay, good. So permutation, we're going to write this in all caps. Order matters. Order is very important for... Order matters. Very important for permutations. In a combination, order is not important. So, order not important. So for all these problems that we look at today, we're going to be making a decision once we read the problems. Does order matter? Does it not? Example 4. 4 out of 17 students will ride in a car instead of a van. Right? So we've got 17 students, and only 4 of them are going to get to ride in a car. Now we have to make a decision. Does the order matter that the students ride in the car? Are we choosing what seats the students ride in the car? No. Okay, so I'm glad you guys aren't saying that. It doesn't matter if you're sitting in the front seat, the back seats, the third row. It doesn't matter. Order's not important. Out of the 17 students, we just need to pick 4 of them to ride anywhere in the car. Therefore, this example is going to be a combination. And on the back side of these notes, we're going to actually compute the possible number of outcomes based off of this. But for now, we're just making some decisions. Okay. Now look at example 5. A team of 11 basketball players needs to choose a captain and a co-captain. All right. Now, why did I put those in boxes, guys? Yeah, because it's important who gets picked as the captain and who gets picked as the co-captain. When you're thinking about basketball players, when you're thinking about sports teams, some people are very picky about whether they want to be the captain, the co-captain, or just a player on the team. Order's pretty important here because you can't have a captain and a co-captain be the same person. Therefore, this example is going to be a permutation. All right, let's flip to the back page and actually compute some answers. All right. So look at the bold right above the problems. State if each scenario involves a permutation or combination, then find the number of possible outcomes. The student body of 30 students wants to elect a president, a vice president, a secretary, and a treasurer. All right. So let's do this problem one part at a time. State if each scenario involves a permutation or a combination. The question we have to ask ourselves, does order matter? Oh yeah, oh yeah, oh yeah. President, vice president, secretary, treasurer, those are specific positions that this student body is running for. Order matters. And now that we know it's a permutation, let's go ahead and compute how many possible outcomes there could be from this scenario. All right. So we know it's going to be a permutation. On the left side of the P, we put the total number of students that we're choosing from. Okay, so how many total students are in this student body that we're picking from? Good. It says right here 30. Okay, now the tricky part is figuring out how many positions are actually being elected, because that's the number that we put on the right side of the P. Okay, we've got a president, a vice president, a secretary, and a treasurer. Therefore, we have 4 positions that we care about. All right. Once we've got that, we can go ahead and dive back into our calculators. So we're going to have 30. We know it's a permutation. And there are 4 positions being elected out of this student body. Whoa, good Lord. All right, look what the calculator's telling us. It's saying that just out of 30 students, if we pick 4 positions, there's over 600,000 ways that this could happen. All right, now think about our senior class here at the school. We have way more than 30 students. Could you imagine how many possible outcomes there are out of the 125 seniors that we have right now when they're picking class officers? There's a ton. A ton.